Okay, so let's try number 11 or number 34 and 11.3 with the like algebraic old school approach.
Awesome.
So here's a picture of a function. They tell you that this is -1, obviously that's 0, this is at 1.
I don't know, that doesn't look that obvious. It's not touching me.
Oh my god, you guys are so...
No.
Hey, it was not just me, okay?
There,
Good.
take that.
That's good.
Art critics don't lie to you. Alright, so what do I know about this function here?
Well, you know it crosses the x-axis once, twice, and it hits it 3 times. So it
Yeah,
hits it
so
3 times.
it definitely crosses once, twice, and then hits it one more time.
At 1.
So it's definitely at least a
3.
It's a cubic.
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 Is that a picture of a cubic though?
Non-dog.
How is it not a cubic?
Because odd goes.
Yeah, because both the tails match, right? So it's definitely 4th degree.
Yeah.
Also, this touch and turn thing,
Mm-hmm.
that means that that guy gets in there twice.
Oh, right, because it's an x equals the same
It's-
number.
Back
in, back
out.
So that 0 counts as 2. One way you could kind of convince yourself of that is if you push this thing up or down just a tiny little bit, like if you pushed it down a tiny little bit, you'd have 4 zeros, right? You guys see that?
Yeah.
And the fact that there's 4 zeros there means that you'd have to have a 4th degree polynomial. That's cool with that?
Yeah. Cool.
Okay, so I know that I have, let me write things that I know. I know this is degree 4,
Sweet.
at least, or more. Right? If it's more than degree 4, what else do I know about it?
It's definitely even
It's definitely even.
and positive.
Positive?
Because it's funny.
Oh, I see. And the coefficient on the, yeah, okay. So you know you have a positive coefficient on your x to the 4th or whatever your kind of leading term is.
X to n.
Okay. Cool. What else do you know?
We obviously know those 4 points.
Yeah, you have zeros at -1, 0 and a double 0 at 1.
A double 0.
So your zeros are -1, 0, 1, and 1.
Yep.
You could have way more zeros at 1.
Okay.
Right? You could have 10 zeros at 1. Probably don't, because it'd be really, really flat there if you did. And it's not that flat. Pretty sure. You guys all see that? Like, if I kind of look at this, that looks basically like a parabola in just that little piece, right? If it was way flatter, like if it looked like a, what do you call the degree 4 ones? You guys remember?
What?
Degree 4. They go quadratic, cubic,
Tetrahedral.
no.
Nice. I know
Hyperbolic.
Quartic. Quintic is the next one.
Octahedral.
I don't like that.
Quartic? It's quartic?
Quartic.
is
Quartic.
Like a quarter, but then it's ick.
Like a quarter.
Okay, at any rate, the fact that there are these zeros means that there are factors.
Ooh.
And the factors, because of the zeros, are
X plus 1,
x plus 1.
X minus 1.
You guys see that? The minus 1, right? The fact that there's a 0 at -1 means that x plus 1 is a factor.
Yep.
One's just an X.
One's just an x. Really, that's an x minus 0.
And there's an X minus 2, X minus 1.
And there's an x minus 1, and then another x minus 1.
Can you square that? Just the x minus 1 squared?
Ooh. Yeah, and you could write that as x minus 1 quantity squared if you wanted to. Please note, if you multiply all this junk together, what do you get?
Something
The
amazing.
function.
probably that function.
Hopefully.
X to the fourth.
Yeah, at the very least, you get an x to the fourth out of all the first things,
Plug
right?
it in my calculator real
You
quick.
see that?
Yeah.
So they gave me one further thing that I need to check, right? So right now, I think I have a pretty good guess, and my function, did my function have a name?
John.
Steve. I like Steve.
It's F.
Bill.
We'll call it Bill.
How come you got Bill?
Okay, so right now my best guess is that Bill looks like these things multiplied together, which you don't have to multiply out. FYI. I'm going to go with Levi's suggestion of squaring x minus 1.
Saving.
Okay, one thing, you're not sure that this is what it looks like, right?
Mm-hmm. Putting the graphing calculator.
So you shove it in the graphing calculator and see, maybe.
Graph it.
Or what's the other thing you could add to this that would also be really an option? Like so far I've got all the zeros, right? So I can't adjust where the zeros are happening, but what could I adjust?
Like just the order.
Horizontal or vertical stretch,
Yeah, you don't want to do a horizontal stretch because that'll change where the zeros are, right?
but vertical.
But a vertical stretch won't, right?
Right.
You can't do a shift because the vertical shift would screw up your zeros, or it would move them. Like if I move this thing up, that one doesn't even hit anymore.
I see.
You see that? Or if I move it side to side, the zeros would change. But I could at the very least stretch it up and down. So there might be a number here, like a constant k.
That's a letter.
That's a letter representing a number.
Yes, yes.
It's
Why is K always
constant.
Cut.
Convention.
Convention constant.
Because it sounds like C and C is a shitty variable choice.
Let's go.
Why?
Because C looks like a parenthesis.
Convention constant.
So, wait. So, I have one more piece of information.
Yep, that random dot. Right
They
there.
told me that this thing goes through the point 1/2 comma negative 27/16.
Three swags.
So you better plug in negative 1/2 and see if you get negative 27/16.
And if you don't,
If you don't, then you need to adjust your k.
Well, I want to adjust by K.
Let me show you.
So
So,
basically solving for K.
bill of negative 1/2, right?
Cool.
On the one hand, that ought to be negative 27/16, right?
Yep.
And on the other hand, it should be what you get when you plug negative 1/2 in here.
Yep.
So if you plug negative 1/2 in there, you get, let's see, negative 1/2 plus 1 is positive 1/2
I'm thinking
times negative 1/2 times, let's see, negative 1/2 minus 1 is negative 3/2
Squared
squared. Okay, so all told here, I got, see, I got 1, 2, 3, 4 2's on the bottom. So I got an over 16.
Well, that's pretty.
That's cool, that matches. And on the top, I got a k times 9. What did you guys just screw up just now?
negative.
Negative. So you got a negative k times 9.
So
So you just need to multiply by
times
3.
Yep, so
So K is
k has to be 3.
Nice.
3. Cool.
Oh,
So you go back here and you put 3 in. And then there is in fact a formula for bill of x. At least, wait.
At least for that point.
At least in the 4th degree case, right?
Oh,
Like it could still be degree 6. You guys see that?
Yeah.
Like there could be some business going on further up here that does something else. Or you could multiply this whole thing by x squared plus 1 or something, and that'd change your constant k. Right? But otherwise you would need at least these pieces. Like these pieces I'm sure are in there. I'm sure k is positive. I'm not totally sure that there's not something else over here. I am totally sure that whatever it is over here couldn't be equal to 0. At least assuming that I have a picture that includes all the zeros. Like if it goes way up and then comes way back down over here and goes back up again, there's no accounting for that.
What if one of those things that went up and then down, up again, somewhere higher up, so you couldn't hit that part on the
Yeah, so if I had a little bobble like this up here,
Yeah.
that'd be a harder problem to solve.
Especially if they didn't give us any points for it.
Yeah, if they didn't tell you where that was or how high it was, you'd be kind of SOL on figuring out how
The
that
page
is.
probably folded when they were printing your textbook. That's probably that's what made it fold.
So if this had happened, we would probably want a calculus technique to deal with that. We could do it at a pre-calculus level, but it would be really nasty, so I'm not going to do it.
I appreciate that.
You could do this
No, no, we're
and then
good. We're
draw
good.
another line up there and pretend that other line was 0 and fiddle with it some more and then try to cram those things together. That would be really nasty. That's like a A++ level question.